Hello everyone. In this video we're going to be solving an exponential equation. Now what makes this equation interesting is that the bases are different, so you can't just get away with substitution. Can you log both sides? Can you use logarithms? Again, the problem is the bases are different, so we have to use a different approach, a non-standard approach. So this is what we're going to do. We're going to divide both sides by 2 to the power x. Why? You'll see in a little bit. But before we do that, let me write 3 to the power x over 2 as square root of 3 to the power x. Why? Because you can write square root of 3 as 3 to the power 1/2, or you can write the 3 to the power x over 2 as 3 to the power 1/2 to the power x, and this is what you get from there. So this is my equation, and I know that at this point some people are just going to guess and check their solutions. But we do need a more systematic approach. So at this point, I would like to divide everything by 2 to the power x. Let's go ahead and do that and see what happens. Divide by 2 to the power x, divide by 2 to the power x, and divide by 2 to the power x. Great. Now, what does this give us? This gives us something super duper nice. Okay, I'd like to take the right-hand side and put it on the left-hand side, so switch sides. So since both of these expressions here have the same exponent, I can basically write it as square root of 3 over 2 to the power x, right? Plus, and I can do something similar here. 1 over 2 to the power x can definitely be written as what? 1/2 to the power x, just like the first one. Okay, great. And what is 2 to the power x divided by 2 to the power x? That is equal to 1. And obviously 2 to the power x can never be 0, so this is not going to be a problem. Okay, everything looks good, but notice that our equation looks much nicer. Now you might be asking, like, why does this look nicer? Well, x is in the exponent, so that's problematic, right? It's a non-standard equation. But take a look at this. What do these numbers remind you? Square root of 3 over 2 and 1/2. Sine and cosine, right? Well, basically this reminds you, or this should remind you, the 30, 60, 90 triangle. Beautiful. What is that supposed to mean? Well, it means that the Pythagorean theorem applies here. Remember, in our geometry puzzles we used it, but we can also use it in algebra. So we do know that x equals 2 works. Why? Because if you square root 3 over 2 and you square 1/2, you get 3/4 plus 1/4, which is equal to 1. Great. So x equals 2 is a solution. But here's the million-dollar question. Is that the only solution? Are there any other solutions? Are there infinitely many solutions? That's what we're going to answer here in the rest of this video. So what am I going to do next? Well, this is what I'd like to do. I would like to prove that there are no more solutions or something else, right? Well, how can you show that x equals 2 is the only solution if that's the case? Or if there are infinitely many solutions, how do you show that? Now, here's what I'd like you to notice. We know that x equals 2 is a solution. So what happens if x becomes greater than 2? Let's take a look at that. So there are two approaches here, and I'll show you both. Okay, so if x is greater than 2 here, then square root of 3 over 2. Now, notice that root 3 over 2 is less than 1, right? Okay, so these numbers are less than 1. That's why we see them on the unit circle, right? Okay, and 1/2 is also less than 1. So when you raise them to powers that are greater than 2, you're going to get smaller and smaller values, right? As x approaches infinity, basically these quantities are going to approach 0, obviously, right? So they're going to get smaller. What is that supposed to mean? Well, it means that this expression here is going to be less than, when x is greater than 2, this expression is going to be less than 3/4 because it's 3/4 at 2. And the other expression, 1/2 to the power x, is going to be less than 1/4. So when you add these two expressions side by side, which is supposed to equal 1 based on our equation, their sum here is basically going to be less than 1. So that means it's not going to equal 1. So anything greater than 2 is not going to work. Okay? So we need to find something else. What happens if x is less than 2, right? Let's take a look at that one as well. Well, if x is less than 2, then square root of 3 over 2 to the power x. Now notice that as x gets smaller and smaller, think about the negatives, think about 0.1, stuff like that. The answer is going to get larger. So this is going to be greater than 3/4. And the same thing applies for 1/2 to the power x. It's going to be greater than 1/4. So their sum, which is the left-hand side of our equation, √3/2 to the power x plus 1/2 to the power x is going to be greater than 1. What is that supposed to mean? We want it to equal 1, but it's just like less than 1 or greater than 1, which means that anything in this interval is not going to be a solution. So if x is less than 2, there are no solutions. If x is greater than 2, there are no solutions. If x is equal to 2, then we have a solution. And that is the only solution. Great? Okay, cool. Now let me show you the second approach. And the second approach actually entails something else. What is that? Okay, let's write our original problem. Well, not the original one, but the modified one again. And I'd like to show you something real cool here. We're going to use some analytical geometry to explore the second option. Okay, we want this to be equal to 1, right? Okay, great. Now, how is that possible? At x equals 2, we know that it's possible. So x equals 2 is definitely a legitimate solution. Okay, cool. Now, notice the function on the left-hand side. If you call this y equals f of x, it's a function of x. And notice that √3/2 is less than 1. So any number like base b to the power x, if b is less than 1, it's going to be a decreasing function. As you know from exponential functions, the graph is going to look like this. It's going to be a decreasing function. So this is a decreasing function. This is a decreasing function. Their sum is also decreasing. And you can kind of show that with calculus by taking the derivatives. So this function is a decreasing function. What is that supposed to mean? Well, y equals 1 is another function that is a horizontal line. Therefore, they are going to intersect at 1 point only, because this is a horizontal line, this is a decreasing function, whatever that looks like, right? Doesn't matter. They're going to have only one intersection point, and that's going to be at x equals 2. So that's the only solution, and this brings us to the end of this video. I hope you enjoyed the video. Please like, comment, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.